So those of you following along at home, uh, just go ahead and message me. I do see something somebody sent me privately. Hey, look, I know people that have been in that situation. That's why I'm not doing any hard deadlines. I do want to remind people with that, not going to put this person's personal situation out there. But look, I understand things are happening right now. I understand with COVID, sometimes things might not be the easiest. But if you need another week to get things in, I'm running loose deadlines. So I think I put the deadline for the 1.1 homework as like today. But if I get it next week, I'm going to grade it like it came in on time. Okay. I'm not marking you late on work. Just get it into me. Just try your best to keep up with the deadlines. This way, you don't fall too far behind. But hey, you got something going on and it's going to take you an extra week to get some work done. I don't mind. So, some of our basic vocabulary with uh, the 2.1. So, we're going to learn about functions here. So, function relates one set of numbers to another set of numbers. Domain are your x values or your inputs. Range are your y values or outputs. Same idea with independent and dependent variables. Your independent variables are your x values because nothing affects them. You decide them. Your dependent variables are your y variables because your y depends on whatever your x value is. So, rule, yeah, okay. A rule of correspondence, a rule of correspondence that matches the quantities from one set of numbers to another set of numbers is a function. In functions, it can be represented by ordered pairs. The first coordinate is the x value, second coordinate is the y value. So pretty much just a regular old ordered pair point. We've been using them for a while. Okay, some characteristics of a function. These are very formal mathematical things being said right here. Look, we're going to just break down what it is in just a little bit, but here's the formal mathematical way of stating things. Each element in set A must go to an element in set B. So if you have something where you're starting, it has to go to somewhere else. Some elements of B may not be matched with A. So if I have a group of things over here and a group of things over here, what's on the one side might not necessarily have to go to everything on the other side. A good example of that actually is a quadratic. So like the quadratic x squared, I don't go to any of my negative y values, and that's okay. Two or more elements from A can go to the same element of B. So again, if I think about the example of a quadratic, if I say 1 squared, that's 1. If I say negative 1 squared, that's also 1. That's okay. But an element of A cannot go to two or more elements in B. So I can't have like negative 1 go to 1 and 2. It can't go to two different places, and we'll talk about that in a second. So each input only goes to one output. That's our big takeaway there. Lots of formal vocabulary there, I know. We're going to take a look at that in a second right here. If the input value of a relationship is matched with two or more output values, then it is not a function. Some common ways to represent functions, equations, that's our most obvious, that's what we're going to focus on. Graphs, set of points, and a table. So right here, I have a set of points given to me in the form of a table. So is this a function or not? Let's see, 3 goes to 5, or sorry, negative 3 goes to 5. -1 goes to 2, 0 goes to 5, 2 to 3, 4 to 14. Each x value only goes to one y value, so this is a function. Now, what I'm going to do quickly, and I'll erase it, if I add something on here, if I do something like 0, 4, now I have 0 going to 5 and 0 going to 4. That's the same x value going to two different y values. With what I added in blue, that would make it not a function. But that's what I added, so I'm just going to erase that. That's just more of a quick example for you there. Okay. Moving on. Again, if you have questions, for those of you virtually, just use the chat. Those of you physically in front of me, I can see where you're at. So, function notation. The symbol f of x is function notation for the value of f at x, or simply f of x. The symbol f corresponds to the function f given x. Keep in mind that f is the name of the function, whereas f of x is the output. In function notation, the x is the independent variable and f of x is the dependent variable. Now, with function notation, I don't always have to use f of x. If you have multiple equations, you could be like, okay, the first one's f, the second one's g, the third one's h. You can use different letters to represent them. And actually, that becomes very helpful in the idea of programming, because if we're programming things, if I have multiple functions, if I said y equals, y equals, y equals, that get very confusing, right? But if I say, hey, this one, I'm talking about f, now I'm talking about g, now I'm talking about h, it becomes very easy to distinguish those functions. So let's take a look at this. I'm going to show you how to do this by hand and with Desmos. You're going to be like, wow, Desmos is really easy for this. So here with this, f of -2, so that tells me plug -2 in for this. So this would be f of -2. Wherever I see a variable, I am going to put in -2. Cubed minus 5 times -2. 2 squared minus 7 times -2 plus 13. So I'm just going to evaluate this by hand. Let's see. So f of -2, that's going to be 4 times -8, because -2 cubed is -8. -2 squared is 4, so 5 times 4. Let's see, I can multiply that together to get a plus 14 plus 13. So let's see, that's going to be -32 plus 20 plus 14 plus 13. See, -32 plus 20, that's -12 plus 14 will take me to +2. Plus 13 will be 15. So that's how I just do it by hand. Now look, Desmos is going to be easy. It tells me f of w. I'm literally going to type in this equation into the first line, and I'm going to say, hey, it's saying f of -2. Let's plug in -2. And Desmos doesn't even make you type out this whole thing. Once you've typed the original function, you can type it just like this and it spits it out. So Let me pull up Desmos here. There we go. So again, oh, just some quick reminders here. Again, move the homework back a day because we just started a day later. Remember, everything is in this week's folder. It seems like you guys are doing a pretty good job with finding stuff. But if you do have issues, please just let me know. So again, you go to Desmos, graphing calculator. Okay, so I'm going to type in my equation. It said f of w is equal to, so it started out with positive, right? Come on. For the, yep, okay. So I could say 4w cubed minus, I believe it was 5w squared minus 7w plus 13. Let me just double check that is right. Yep. So it graphs it for us. I could go to negative. I might have made a mistake in this. Because if I go f of -2, well, f parentheses -2, I got -25. Oh, I know where my mistake was. I made a silly mathematical mistake here. I changed this. I accidentally messed up a sign here. 5 times 4 is 20, but I had a minus sign in front. So now -32 minus 20 takes me to -52. Then let's see, those together are 17 or 27. -52 plus 27 is -25. So it was just a little mistake on my part. I accidentally missed the negative sign here. I accidentally wrote it as a plus 20. That's why my answers didn't gel right away. But again, if I type it in just how they said, Desmos can do a lot for us here. Now, if the next problem has me do another equation that's f that's different, I'm going to want to change up the equation I put in there. But that is something we can do. Okay. Let's take a look at the next example. Okay. A piecewise function is a function defined by 2 or more equations. So in this is an example of a piecewise function. I'll show you how to handle it on Desmos as well, but first we're going to do it by hand. So when x is less than 1, I have to use the top equation. When x is greater than or equal to 1, I use the bottom equation. So right away for the first one, x is equal to 0. Well, 0 is less than 1, so it's going into this top equation. So I'm going to start with f of 0. That's just going to be 0 squared minus 2. 0 squared is 0 minus 2 is -2. Now, for the next one, oh, I had already used, okay. X is equal to 1. Well, x, or sorry, you want to write x there. I know 1 is greater than or equal to 1. So that tells me I should be using my bottom equation for this one. So I do f of 1, that's going to be 2 times 1 plus 1. 2 times 1 is 2, plus 1 is 3. And that's how we do that by hand. You're going to use these inequalities to help you out. Now I'm going to show you how we can do this with Desmos too. You're going to have to do two different equations. So I know this one says simply f of x. I'm going to call the first one f for the top part, and then the next one g. If I have three parts, I might do f, g, and h, or whatever letters I'm liking that day. Just avoid using vowels, because E and I are both defined as numbers, so it will start confusing Desmos if you use them. So that's why I'm going to say stick to consonants, just because we do have some vowels like E and I defined as numbers. So here's what I'm going to do. I'm going to type in the first part, including the domain restriction. So let's get these deleted out. We'll also see how to graph a piecewise function this way too. So I'm going to start f of x is equal to x squared minus 2. However, this is defined across a particular domain. So then I want a curly bracket, and I'm going to put what's in this back half here. X is less than 1. X less than 1. So now all of a sudden my graph gets cut off. Now I'm going to do the same thing for g of x. You do not want to call them both f of x, because then it's going to start confusing it, because if I try and say f of a certain number, it's going to go, well, which f function? I don't know. That was equal to 2x plus 1. And that had a domain restriction of x is greater than or equal to 1. And now I have this graphed. So I see both parts. Now I was looking for the value at 0. Watch this. If I plug in f of 0 here, it gives me that value, because that f is defined there. But if I try and do g of 0, notice it tells me g of 0 is undefined. 0 is not a part of g's domain. So if I'm getting undefined there, I don't worry about that one. I worry with the one that gave me a value. We could do the same thing with 1 is the other thing we were plugging in. So I could go f of 1. That's undefined. But g of 1 is defined. So again, we get those same values we had before. So I did it by hand and got the same answer. So again, not seeing any questions in the chat. Looks like you guys are doing pretty good in front of me. So let's keep going with the notes. So the implicit domain is a function, is the set of all real numbers for which the function is defined. In general, the domain of a function excludes values when you divide by 0. So if you ever see x in a denominator, you're going to need to figure out when you're dividing by 0. And or you take the square root of a negative number. So actually, let me add just slightly to that. So if x is in a denominator, set it equal to 0. That's where it will be undefined. And if x is under a square root. Say it's greater than or equal to 0, and then solve. We'll take a look at that in a second. So if I think of a square root, again, we can't take the square root of negative numbers. Try to think, IM3, actually, if I had you for honors, IM2, I know we touched on imaginary numbers. If not, you should have maybe seen it in IM3, but I know imaginary numbers might have gotten cut off last year if you had IM3 in the spring. So when we get to imaginary numbers, I will make sure to get that down. So let's take a look at this in motion. For example, the implicit domain of this function. This is a square root. What I'm going to do is I'm going to take what's underneath the square root and say this is greater than or equal to 0. Does that make sense? Just whatever underneath, just say, hey, it has to be bigger than 0, because as soon as I start getting my negatives involved, so good. Now it's easy to solve. This one's going to have a fraction answer. When you solve problems like this, it's like what, 8th grade at least? Or not a negative answer, a fraction answer that I can divide by 5. And I'm just going to leave. I want you guys to get in the habit for pre-calc of just leave answers as fractions. We'll see why when we get to trigonometry a little better, but just leave your answers as a fractions. Yes, I know, what would that be? 1.6 is the same thing, but I know what 8/5 is very easily. It makes sense to me. So the implicit domain is x has to be greater than or equal to 8/5. And that's it. Okay. So here with this, use this function to find the, okay. So P is the price in dollars of a child's handmade sweaters given by this function here. Oh, they need to be charging more for that. P of S is equal to 3S plus 15, where S represents the size. Find the price of a child's size 5 handmade sweater. So all I'm going to do is plug 5 into this. This is such an easy equation. I'm not going to bother plugging it into Desmos at all. So 3 times 5 is 15. 15 plus 15 is 30. So what's the price? The sweater is $30. Yes. Oh, I must have been in the hall. Okay. I thought I heard one of you go, oh, cool. I just want to make sure. So all we did was plug in the size it said. Again, I'm thinking $30 for a handmade sweater. Seems kind of cheap. Oh, wait. I forgot this book was published quite a few years back. So still a little on the cheap side, but they probably could be charging more today. Okay, let's take a look at this slide here. Okay, so with this, okay, I'm about to show you something a little bit crazy looking. This is something you're going to see in calculus. Please do not freak out about this problem. I am just showing it so we get this knowledge before you see calculus. This right here is called the difference quotient. Essentially, it's the idea of slope, where h will be the distance you cover on the x, and f of x plus h minus f of x is the difference in your y's. I've given a fast explanation here. I doubt we will. We have time to talk about limits in this class. I'll get more into this, but I'll save that more for your calculus teacher to do. So what I'm going to do here is I'm going to plug x plus h in for x and then subtract off the original. Please just follow along. I know this one's going to get a little crazy on us, and if you're struggling with it, this is just me previewing an idea. Don't freak out about it. So I'm going to start with the first part. Wherever I see x, I'm replacing it with x plus h. So I have x plus h squared minus 4 times x plus h plus 7. Then I need to subtract out the original function. So I'm going to put that in parentheses. And then the whole thing is just over h. Now I'm going to move slightly fast here. I'm going to FOIL this out. This is actually x plus h times x plus h. So when I multiply that out, that's going to give me x squared plus 2xh, or hx is probably more how I should have written it, but it doesn't really matter, plus h squared minus 4x minus 4h plus 7. Then I'm going to distribute this negative sign. And that's going to be x squared minus x squared plus 4x minus 7 all over h. Let's start seeing what like terms we have. I have an x squared and an x squared. Those actually cancel because one's a positive, one's a negative. See, no other xh's, no other h squareds. Okay, a minus 4x and a plus 4x cancel. No h's. A plus 7 and a minus 7 also cancel. So what that leaves me with is 2xh minus 4h and a plus h squared. That's what I was missing. All over h. Now, since they each have an h in them, I can have them cancel out and reduce, and that gives me 2x minus 4 plus h. If I said h was equal to 0, I'm left with just 2x minus 4, and you will learn, once you learn about derivatives in calculus, yes, the derivative of f of x is 2x plus 4. When you get into calculus, look, this is just going to be like just 2-3 weeks of doing this, and then you're going to learn a shortcut to go from this to this. There is a shortcut to it because this is doing something very deliberate. I'm going to save all those details for your calculus class, but just giving you a preview. I'm not going to be asking you to do stuff like this all the time. I'm literally just previewing future material. So please don't freak out about it. Okay. Here, this is the group of problems for your homework. Again, that can be found if we go into our Schoology page. If I go to today, And you will see, I think I should have moved the due date to Monday for this homework. So if I go under major activities, oh, I'm in week 1, not week 2. We won't find it in week 1, we'll find it in week 2. So if I go to Thursday, I need to delete that Wednesday folder. It's unpublished. There's nothing in there for you guys right now. If I go under major activities here, we see, oh, because I initially assigned it on Thursday or on Wednesday, but we still see in here when it says homework continued, that just means, hey, the lesson took more than one day. I'm not assigning it more than once, but here are the numbers. Here's the ebook. You just can't submit on this one. You'll have to go and submit it on inside Tuesday's folder because that's when we first did it. And again, we see on the side, oh, I did put the due date as Friday, but if you need the weekend, that's no big deal. Please, Samar, if you do have questions, please come with those. So that is recorded. Inside of today's folder, I will make sure to put this lesson there. Stop recording.